All right, let's jump right in. We're going to talk about a number today. But look, this isn't just any number. This is a number that was literally born from a crisis. It was given its name as an insult, and for hundreds of years, it was treated like a mathematical ghost. This is the wild story of I, the imaginary unit, and how it went from being an impossible joke to an absolutely essential part of the language we use to describe reality itself. So, where does this whole story kick off? Well, it starts with a whole lot of rejection. When the brilliant philosopher and mathematician René Descartes stumbled upon the square root of a negative number, he didn't see a new opportunity. He saw nonsense. And he's the one who slapped it with the label imaginary. And trust me, it was not a compliment. It was his way of saying, these things are phantoms. They belong in your imagination, not in the real world of math.
Okay, but now let's fast forward a few hundred years, and you get a completely different take from Nobel Prize-winning physicist Richard Feynman. He's looking at an equation built on this exact same number, and he calls it our joule, and the most remarkable formula in mathematics. So what happened? How in the world does something go from being a mathematical joke to a scientific joule? That's the mystery we're going to piece together today.
All right, so to really get what a revolution this was, we've got to go back to a time when I was a complete and total outcast.
You have to remember, back in the Renaissance, math had to be real, like literally. A number had to represent something you could actually measure. The length of a rope, the area of a farm, the volume of a wine barrel. You know, even negative numbers were kind of sketchy, because how can you have a farm with negative area, right? So in that world, the idea of a number that when you square it gives you a negative result, that wasn't just weird. It was a logical impossibility. It just broke all the rules.
So if it was so obviously impossible, why didn't they just toss it in the trash and forget about it? Well, the funny thing is, they couldn't. A completely different problem, a high-stakes race to solve cubic equations, ended up forcing their hand and turning this outcast into the most unlikely hero. And the backstory here is amazing. It reads like a thriller, seriously. In the 1500s, finding a general formula for cubic equations was a huge deal. A mathematician named Tartaglia cracks it. He finds a secret method. He gets pressured into sharing it with a brilliant but kind of shady guy named Cardano, making him swear a solemn oath not to reveal it. But what does Cardano do? He not only figures it out, he improves it, and then he publishes the whole thing. This kicked off one of the most bitter feuds in the history of math, but it also unleashed a really deep, really troubling paradox on the world.
And this is where things get really weird. It's called the casus irreducibilis, the irreducible case. See, Cardano's fancy new formula worked, but it had this bizarre side effect. When he used it on problems that he knew for a fact had three perfectly normal real-world answers, the formula itself made him take the square root of a negative number in the middle of the calculation. Think about that. To get to a real destination, you had to take a detour through an imaginary land. Cardano saw this, but he basically threw up his hands and called it as subtle as it is useless.
The real breakthrough came from an engineer, a guy named Raphael Bombelli. He was a practical man. He basically said, look, I don't know what these things are, but what if we just pretend they're numbers and give them a rulebook? So he did. He laid out some simple rules of the road for how to add and multiply them, with the key rule being that this new thing, I, times itself is -1. And you know what? It was magic. When he followed his own rules through Cardano's complicated formula, the imaginary parts would always, perfectly, cancel each other out at the end, leaving him with the correct, real answers. He hadn't solved the mystery, but he'd given it a user manual.
Now, for about 200 years, that's all I was, a weird but useful trick. But the real revelation, the game changer, came when mathematicians realized they'd been looking for I in completely the wrong place.
The giant leap forward was realizing that numbers don't just have to live on a single line. For centuries, everyone pictured all numbers, positive, negative, fractions, laid out on one long number line. The reason nobody could find the square root of -1 is because it doesn't live on that line. It lives in a whole new dimension. The big idea was to create a complex plane, with our familiar real number line running horizontally and a new imaginary number line running vertically. And just like that, I wasn't a ghost anymore. It had a place, it had a home, right there at the coordinate 0, 1.
And this, right here, is the beautiful aha moment. This shows you what I really is. It's not just a number. It's an action. It's a command. Rotate 90 degrees. Okay, follow me on this. Start at the number 1 on the real axis. Now, multiply by I. Boom, you rotate 90 degrees and land on I on the vertical axis. Do it again. Multiply by I a second time.
You rotate another 90 degrees, and where do you land? Right on -1. So I squared equals -1 not because of some weird arbitrary rule. It's because two 90-degree turns make a 180-degree turn. It's just geometry.
This whole geometric idea really hit its peak with what's often called the most beautiful equation in all of mathematics, Euler's formula. Now, what this shows is something just profound. The number e is all about exponential growth, things getting bigger, faster. But the second you stick an I up there in the exponent, all that runaway growth transforms into perfect, endless rotation, into waves and cycles. I is the magic gear that connects the world of growth to the world of oscillation. It proves that I isn't some weird outsider. It's a deep, central, unifying piece of the mathematical puzzle.
So once the mathematicians figured out what I was all about, the scientists and engineers were like, wait a second, this is exactly what we've been missing to describe the real world.
Take a look at a classic example, AC electrical circuits. Before complex numbers, trying to analyze these things was a total nightmare of trigonometry, trying to keep track of both the voltage's strength and its phase. But then engineers defined a single complex number they called impedance. The real part is just good old resistance, and the imaginary part handles the phase shift. And with that one move, the whole messy calculation collapses into a beautifully simple equation. V equals I times Z. It looks just like the Ohm's law you learned in high school, but it's been supercharged. And that imaginary part isn't imaginary at all. It's describing the very real physics of what's happening in the circuit.
But look, if I is useful for engineers, it is absolutely non-negotiable for quantum physics. This is the Schrödinger equation, the fundamental rulebook for how the quantum world works. And you see that little I sitting right out front? It's not just there for decoration. You can't just erase it. The entire theory of quantum mechanics literally falls apart without it. It's there because the wave function, the thing that describes a quantum particle, has to be a complex number. To describe reality at its most fundamental level, you need that extra dimension that I provides. It's just built into the fabric of the universe.
And the list of applications just goes on and on. In signal processing, I is the key to breaking down any complex signal, like a sound wave, into its pure frequencies. In control theory, engineers use the complex plane to figure out if an airplane's autopilot is stable or if it's going to spiral out of control. Even something like modeling the flow of air over a jet wing becomes possible using complex numbers. It really is the ultimate Swiss Army knife for science.
Okay, so I is this powerhouse tool for understanding reality. But, and this is the final, absolutely beautiful twist in the story, it turns out it's also a tool for creating infinite, breathtaking art.
And it all starts with this ridiculously simple little recipe. All you do is take a complex number, z, you square it, and then you add a different complex number, c. That's it. That's the whole rule. But when you do this over and over and over again in the complex plane, something extraordinary happens.
You get this? The Mandelbrot set. This wild image is basically a map. Every single point you see represents a different number c that we can plug into our simple little recipe. Now, if we run the recipe over and over and the result stays put, doesn't fly off to infinity, we color that point black. If it does fly away, we give it a color depending on how fast it escaped.
And what you get is an object of, and I mean this literally, infinite complexity. The edge of this shape is a fractal. If you zoom in on any little piece of its fuzzy boundary, you just find more and more detail. You find these incredible swirls and tendrils, and hidden inside them, you'll find perfect, tiny little copies of the entire set, repeating forever. It's an entire universe of staggering beauty, all generated from that one simple rule, all powered by the geometry of I.
So after this whole journey, from outcast to hero, to the language of reality, to an infinite artist, what's the big takeaway here?
The main thing to get is that the name imaginary was a historical accident. It was a failure of imagination. This number isn't some fiction we made up. It's a discovery. It's the discovery of a new dimension to our number system that was always there, waiting. And it's a dimension that perfectly describes rotation, waves, and cycles, the fundamental rhythms of our universe. It's a tool that expanded our whole idea of what a number can even be.
Which really leaves you with one final thought. The story of Allah shows us that an idea that seems like complete nonsense to one generation can become the bedrock of reality for the next. It just makes you wonder, doesn't it? What other ideas that we dismiss today as being merely imaginary are just sitting there, waiting for their moment to reveal a deeper, more beautiful truth about our universe?